Okay, well, we want to give an example of what our standards look like here in Maryland. So we have, unlike the national standards, which go by grade bands, we have standards for each specific grade level that build on each other. So you start with a kindergarten thing, then first and second for early elementary, then you have kind of a suite of third, fourth, fifth, and then so on for middle school and then high school. It continues on through, but you can see how you start with a general idea and build on it in what we hope is an age appropriate way in an area where there's very little research to determine exactly what is age appropriate. I have found that one of the most relatable examples that I can get people to step in the door for computer science and get the idea about how this is doable is to talk about some of these amazing high interest activities that you might use with elementary or middle school kids. And as Elisa and I both like to pontificate on is you could just do the activity and just do the activity and maybe learn nothing about computing or computational thinking. Or you could learn a whole lot about it if you understand the context and call out some of the things that are going on as you do something like this. So in a thing like this, what happens is that you turn on the teachable machine. No special anything needed, works from pretty much any device. There's a whole complete lesson in there that's very nice to go along with it. And you click on class number 1, and you could take like all of your toy horses and hold them different ways and move them around. And it would say, okay, that's a horse. Okay, good. And then you could click on class number 2 and pick something totally different. And I want to see if the computer will be able to recognize it later. So this is a brush, and I move it around and hold it and turn off my virtual background so it actually works. And then I pick something up and I say to the computer, what's that? And it only knows what a horse is or what a brush is. And so it has to sort of guess based on whatever information I gave it to work from. People often do this with cats and dogs. I couldn't really pick them up and hold them, but you can either show it things with the camera, which is the easiest way to do it, or feed it a whole bunch of pictures that you've collected. And in that activity, there's a bunch of active pictures already set up for cats and dogs that they can use as their training set. And the points that people get to make out of it is, well, if you only showed it pictures of tabby cats, then it might only recognize tabby cats. And if all of the dogs have long ears, it might only recognize a long-eared dog. And we don't really quite know how the computer makes its decisions about the patterns of how one thing is like or different than another. And one of people's favorite things is to put out Baby Yoda and ask the computer if it's a cat or a dog, because you got about a 50-50 chance either way, depending on what pictures you started with. But it provides that opportunity to think about how computers depend on both information and an algorithm to analyze things. And part of why a lot of the things computers do now have bias in them is because the data that we have available to us is very limited and based on a history full of inequity. And we take that, feed it into the computer, and get more inequity back out of it again. So people have to be very intentional about what kind of information they feed into a computer, depending on what kind of outcome they want. So how does that translate into standards? So if we look at some of the 4th grade standards here in the area of inference and models, the students are supposed to be able to discuss the potential accuracy of the conclusion or prediction based on how adequate the data set was. So if I show the computer 100 different pictures, it's going to have a much broader idea about what something looks like than if I only show it 2 or 3. And so they can actually do that, right? Things that you actually can do hands-on create more of a lasting impression and something you can talk about with kids. And then when it comes to the impacts of computing and culture and diversity and social interactions, they can talk about how it's important that you get contributions from different people and how it's important that you talk about how it can be improved by collaborating together and getting other people's input and information together. Then bumping it up to the middle school and looking at what a student might get out of that kind of an engaging activity, if you call it out, is talking about, well, how did the computer, where does it actually get stored? How does the camera see differently than how your eyeballs see? And, how do you transform information from the real world into the computer world, and wrestle with that a little bit. And in the culture and diversity, you can talk about so many other things about the ethics and impacts of once you fed that data into the computer, who else might have access to it? Does it matter? And so forth and so on. So I just wanted, if we had our large group, we could do this, but we don't need to do this. So what do you think, since you're my captive audience? Is this something 21st century citizens should know as informed citizens? Nah, totally optional. Let computers rule the world. We'll just sit by. But I'd really like to know, where do you think a lesson like this could be? We could expose education majors to an experience like this to see how you can take a fun and engaging activity and tease out all of these standards that are in there that we're supposed to be teaching.
Oh yeah, I would use this definitely for that purpose. We try to do technology every week that will be incorporated into lessons in some form or another, and coming from the standards, the Maryland standards and the ISTE standards.
Yeah, right. Yeah, we have multiple standards to meet: content standards, ISTE standards,
right,
and computing standards. So it could go into that. That's your tech class is a place where you can use it.
Yes.
Do you think outside of a class that's specifically a tech or tech class, any place else where somebody could make that part of the conversation, that they could use it in a different context, or you think too hard?
I'm not sure if the professors, at least at Garrett, would do it. They're kind of tech stumped.
No. This isn't, it's plausible. This is just where it be taught. Like if we lived in a world where we could convince people like, hey, this would fit in well with what you're doing. Do you think there's any place else it would fit in?
So my initial thing is, like, we're talking about how AI could potentially impact certain areas and the ethical implications and the bias implications. So social studies, traditional social studies could really lean into this. We have plenty of case studies that we could pull from about bias and how that relates.
Become a whole unit, right?
Yes.
Yeah.
You can talk about it in regards to how certain things haven't changed since now my brain has just stopped.
Like Jim Crow,
even from Jim Crow, how certain things have propagated through policing, through anything that you want to talk about in that regard. But you could also talk about it just from the data standpoint. You talked about doing the images. There's things about how machine learning doesn't recognize certain like the soap dispenser issue, right? If you have darker colored skin, sometimes the soap dispenser will not engage, and that's a product development issue, right? And so there's lots of little bits and pieces that could be incorporated into lots of different things.
Yeah, from the design process aspect too. So that's a good point in there.
If you did a machine learning thing within art, do a deep dream creation thing, and you can look at what are the students actually putting into the system and how that influences what comes out of the system.
Yeah, I wonder if we get an art teacher to buy into this. That's a good question.
We have an art teacher. We have some art teachers who are very interested. So that's
you think
actually
they'd be interested in doing this. Like if we showed them how they could use it. We're trying to find some of those soft points. Like some of these activities are so rich and so interesting and so easy to do. Even for somebody who's done nothing with computing before, it just cracks the door wide open. And so, we just trying to get the good minds
think
together
we
to
should-
help us
yeah.
think.
We can ask. I think even for younger kids, like little kids, when you're looking at classifying, like, which is a big thing in like elementary science, then they have to, if they classify and then they look at how the computer classifies, that would be kind of they create two categories and feed them to the computer and then see how their categories hold up for the computer. Am I making sense? Or
No, yeah, that's really good, because like we're saying, like, people have done all these things this way. Well, computers also do these things. So if a computer was doing this job, how would it be different?
Right. And we tend to, in elementary science, have kids sort, and then you have to kind of like exchange with another group and have the other group figure out how you sorted. And so this is like an extension of that. It's like, okay, does the computer then, can the computer figure out how you've sorted? So it's kind of an interesting extension.
I know there's a lot of sorting stuff that goes in there. That's nice. See, I knew there were other places it could go besides just in our computer science classes. Just needed more people to help brainstorm it out.
All the brains.
And I showed this before, but I think, it's really kind of nice if we can get the general educators to be comfortable with something like this, where you can take just as a first step to just be aware that, like, if you've got to break a problem down and get a computer to do it, then there's certain things you have to do with it. And you already do some of these things. You just don't do them as intentionally or with the same severe logic that's needed to take it that step further to put a computer to work to solve the problem. But just raising an awareness that there are these things that we do is a great step along the way. So we're switching over here, right? No, we're switching over
You
here.
have to do this slide because you put it in after we talked. And then no, the next slide is yours, and then I'll take over because I didn't put that one in.
Oh, okay. Yeah, that was when I realized that. So we were going to do this activity that we've done with groups of people before, which is a great opportunity to find out how hard it is to take a process and actually name what the steps are, from a real person thing to a computerized thing, whether it was getting a computer to do perhaps a dance sequence. It's not as easy as you think. And so we were going to do this activity where you break down the steps to describe it to a computer or a robot. And the challenge is to think back on those habits of mind, like think about what you're doing when you're doing it. Which of these things are important in trying to come up with a solution, and how would you benefit from the experience of wrestling with the problem, and what would you get out of it in the end is it. But there's this real cognitive overload here, because if you try to learn a bunch of things, especially new stuff all at once, people just sort of crumble and fall apart, because normally we do this activity in breakout groups, but we're already in a breakout group, so we can't do breakout groups. So if we had large numbers of people, we set it up for the way that our teachers do it when they can't have breakout groups, where you create this little discussion area over here where you communicate silently with your team members as you try to solve the problem. But we don't have to do that. Has Dwayne ever done this one before? I don't know. I see him here, but he might have.
I have not.
All
Oh,
right.
that's nice.
Yeah, so we'll torture the three of you. And you can actually use slide 14. So the idea is that on slide 13, there is the famous Saturday Night Fever dance, and it's actually cropped on the slide, so that if you're in the slides, you can play it from within the slide, because the beginning is, kind of not all the dance, and there's a big kiss at the beginning, so we can ignore that. But then what your challenge is as a group to kind of put the steps in order so that someone could do the dance from the way you've put the steps. So you use these little, if you go to slide 14, use these text boxes and you can add your own. You might have to duplicate some, you can figure out what you want to do. But what you want to do is you want to be in that slide and ordering the steps so that someone else could do that dance. And so we've given you one called Disco Move, which is that move, you know, the Saturday Night Fever move. But the rest of them you can interpret as you want, or as I said, you can make new ones for yourselves. But as Diane was saying, what we'd like you to do is pay attention not only to creating the steps, but also kind of metacognitively. What are you doing? What is the process that you're using to get this done? And we usually give people 4 minutes. So it's up to the 3 of you to figure out how you're going to do it.
So do we watch the video first and then duplicate it?
You tell
You
us.
got to figure it out. That's your job.
Well, I have to know the dance before I can do it.
Okay,
Yeah.
makes sense. I mean, we can project if you tell us what you want to project, or one of you guys, I think, do they have the ability to project, Diane?
Yeah, they can share their screen.
Okay, so if you just, you know, if you want one person to share their screen, that could work too.
The trick is usually we go away at this point and then
Yeah.
people are abandoned on their own. And you're faced with utter silence and boredom, or the option to try out playing the Saturday Night Fever video and figuring out the steps.
So you can talk because there's only one group here. You don't
I
have to
would,
type.
but there's also lunch happening
Oh.
in my house, which is why I keep like dropping off the image, because but my wife, Lindsay, who would normally be in one of these sessions also, is teaching class right now. And so I'm running herd on the kids.
Tell them to join us.
Yeah, they
What
could
are the
help.
steps, guys?
One of them would,
Yeah.
but she is eating.
I love Alan's placeholder. And you know, I mean, that's like the challenge of computer science, right? You know, you've got to take some real world process and describe it to a computer in little minute steps, and they got to be in the right order. But the whole thing about, you know, figuring out the teamwork dynamic, how you're going to communicate with each other, who's going to take control or do which part of it, that's the big part of the computer science learning that people often forget about. And so what's funny is doing something like this, even after just participating for 4 or 5 minutes, people can come away saying, yeah, if I had to do something like that again, I could do it better, because I just figured out, like, we should have done this like right at the beginning, like you should have shared your screen. And but you know, and that's kind of the ahas that we want people to take away from this, and that approaching any kind of computing problem and the collaboration, the teamwork, the communication is just as much of the problem solving process as the actual coming up with some steps, which may or may not be right. And we're not going to grade your steps or anything, but they look like a lot of fun. I'm sure we could all get up and dance it at this point if you watch that sequence enough times.
Any other thoughts about why this is computer science or computational thinking? And
You want my expert opinion?
I do.
It's decomposition.
Mhm. Right.
One of the essential skills, right? Like, we've got this big thing and we're decomposing it into its all little small things.
I mean, to me, it's so similar to writing a program because it's a sequence of steps. You got that disco move, which is essentially a function that you're calling. You know, you have variables. How many times do you walk forward? How many times do you walk backwards? You know, there's so much of, but as Diane said, there's also all those kind of habits of mind. You have to debug. You have to persevere. You really, if to do it effectively, if one person is writing steps and the other person is playing the video, calling them out, maybe that's a collaborative process that works. So it's like all those things put together, but it's in a context that we don't usually think of as computer science. Like dance, it's not usually what we think of, but it, and as you were talking before about art, like all of a sudden you say, oh yeah, it's kind of the same habits of mind are coming through.
I did this exercise from CS Unplugged as part of my my talk earlier, is doing color by numbers. There's a CS Unplugged activity that's colored by numbers with binary numbers and things like that. But just doing the pattern recognition and things like of that nature, even for first graders or kindergartners who are doing the color by number things, those are the habits of mind, like you said, right?
Yeah. Right, and I like that, the mistakes, right? It's fine to make a mistake. I think that's something that we try hard to teach kids, and that, how many computer programs have you ever written, even in the most basic, like when I use Scratch Junior, I still make mistakes. And so that whole debugging, that whole iterating, that's all.
It is amazing how you can like barely write a 6-line program without having some mistake in it. It's like, why?
Yeah. Any other thoughts? Carla or Dwayne?
I'm sort of new to all this coding, so I'm learning as I'm going.
This more
Did that make sense to
definition.
you?
Oh yeah.
Okay.
I've done some of it, but it's definitely breaking it down into smaller and smaller bits, like like Alan's saying, and it's the decomposition that kids have to get to understand before they can understand how to do the whole thing.
Nice. So looking at what's going on in the various levels across Maryland, we figured we'd start with the high school. And so typical computer science offerings in a high school, where virtually every high school offers at least one class. Some of them offer as many 6 different or even more computer science classes. A lot of them have the CTE programs where they get that Perkins funding that comes from the state. That's so very motivating because it's money that keeps coming every year. A lot of them are moving to a 3-course pathway instead of a 4-course pathway, which used to be required, so that kids can take more of a variety of courses, and so that they can maybe do fewer courses better instead of more courses more spread out, especially for smaller schools. So the courses that you're going to see here are because of what was available to us for professional development and curriculum, really. So the code.org courses for CS Discoveries came out pretty early on. They started out as a tech ed course for 9th grade in most of the districts, although many of them are moving them into the middle school. And it's a great survey course that introduces kids first to some general problem solving, some web design, some app design, some game design, a little bit of physical computing using a circuit playground, and they can actually light lights and see some of the challenges of dealing with actual objects. And generally speaking, once teachers teach this course, they just want to keep it. It does keep evolving and they keep getting better. They're great at teacher feedback. Some districts divide it up into like 3 separate courses because the units are fairly separate. Other ones teach it as a full year course. Prince George's County does the first 2 units in middle school and then the last 4 units in high school, combined with some of the projects that used to be in tech ed. So the tech credit is still keeping their favorite hands-on design process while they do software design process at the same time. Although this year, big win, best interactive curriculum available online for kids to engage in. Probably everybody's number one favorite. So number two favorite, AP Computer Science Principles, also very interactive, very well done course that it's wonderful when a teacher is able to facilitate the student learning and make the right connections and work with getting different groups together. But this one focuses more on how the internet works and the impacts and ethics of computing, along with big data and a little sprinkling of programming, not a whole heck of a lot. And it is language agnostic. So some people do it in Python, some in JavaScript, some use Scratch languages, all sorts of stuff out there for that course. And then APCSA is the classic computer science class that people have been teaching with Java. That's supposed to be the equivalent of the first year computer science major course. And the optional fourth courses that are available are everything from Python programming to cybersecurity. There are people teaching artificial intelligence as a course in high school now, along with both app development and web development courses as a fill-in type of thing. But every Maryland kid's got to get a tech credit, and it's got to be either computer science or engineering. So we've got an advantage for the exposure there compared to a lot of other states that it's just an elective. So in secondary professional development, we have, I don't know how many hundreds of teachers we've run PD for over the last few years, but it's a lot. I should have the total number there. But all of these things are out there, and we're inviting our higher ed people. If you want to see what it is that those teachers are experiencing and what the tools look like, to put those into the mini grants and invest some time into finding out what they're doing in K12, because that would be a great thing to do.
Middle school.
Middle school.
So we actually, in middle school, there is a computational thinking requirement, computational learning. And so every student in a Maryland middle school has to have at least one meaningful experience with computational thinking and learning. And the school districts fulfill this in any number of ways. And this is just a quick and dirty estimate, basically, of who does what. And PLTW is Project Lead the Way, and they have a Gateway to Technology series of, I think they have 10 different units. So different districts use different units for different grades, but that's certainly one way. And I believe it's about 14 districts have PLTW, and 5 of them actually have it for all their students, but 14 offer it to at least some of their students. Code.org is the most common one. It's also free, so that helps. Project Lead the Way is not free, but Code.org, there are 19 districts that use it, and of those 19 districts, 11 have all their students doing some of a Code.org class. And as Diane said, some of them actually do computer science discoveries in middle school, others do Fundamentals Express or some part of CS discoveries. There's a bunch of different ways, but what we really want you to see is all the other things that they're using, and many of these districts are using a combination. You can see this adds up to more than 24. So some districts are using Project Lead the Way and Code.org and a few other things. There's a big variety of how the school districts implement computational thinking. Can you go to the next slide? So this is basically has the purpose of this slide is to give you the links basically to all the different resources that people are using to fulfill this computational thinking learning requirement. And so they're the big ones, but there's also a lot of locally developed courses that people pull from various places. Some districts integrate it. So it's integrated into science in a few districts. Oh, I'm missing a parentheses there. And it's integrated actually into business in one of the districts. A lot of districts use Scratch in some of them, one of them uses it to integrate into science. There are curricular kind of resources that they can use Scratch. Another coding tool that people use is Alice in in middle school. There are a bunch of different STEM applications. Tinkercad, I didn't really know where to put because it's like a makerspace kind of 3D printing thing. So I threw it into STEM, but you know, it's technology, so it's STEM. And some districts use a variety of robotics or physical computing resources. So there's really a huge variety of how districts are using these various tools and resources and putting them together to construct curriculum. So that's basically the picture in middle school. Elementary school, there are 15 of our districts out of the 24 districts have some kind of organized district-wide CS in elementary school. 8 of them don't, but that doesn't mean there's no computer science going on there. It just means it's not like a district-wide initiative. And of those, you can go to the next slide, of those districts, there's, you can see that again, many of them use code.org. And so out of these, I believe it was 23 districts that responded here, 12 of them use code.org, half of those, 6 of them use only code.org, 6 of them use code.org plus something else, and the something else is often something designed by the school system. There are 3 districts that don't use code.org at all, which is pretty interesting, of the districts that have some kind of district-wide plan. But then there's also other districts that use, there's robotics, there's Qblitz, there's Boot Up. And I know from like just talking to teachers, there's also a wide variety of things going on at elementary school. This is kind of the picture of what actually goes on in terms of what the district tells them should go on. So there's a lot of variety in terms of what there is going on at the elementary school level. Okay.
Yeah, definitely early adopters in all sorts of different areas there and innovators and all that other good stuff. So we wanted to throw another one at you. This is the one most people get stuck on when it comes to code.org things. And that's because not only do you have to give directions to the computer to move and turn, but you have to give it like specific angles. And of course, when you move and turn once, all of a sudden your perspective has changed, just like in robotics or drones, where you have to follow it around and follow its perspective instead of your own. And so it's a wonderful opportunity to drown a little bit into the challenges where you can both get to know the tool, make lots of mistakes, and work collaboratively on solutions. And because it's art, you can do something really creative with it. So these little hour of code snippet things that are put out for the big hour of code each December give you flavors of computer science and coding in different ways. And so you can see they're also translated into, in this case, like almost 30 languages. So that it makes it also a great tool for people working in schools with a huge diversity of languages, of an activity that everybody can kind of jump in on. So just curious, have you guys tried this one before? Hi! Are you going to help us? All right. Okay, you can share your screen. You show us what to do, and we'll
I'm going to have her do it.
Yeah. I'm going to stop.
All right. Let me do this.
Oh, well, computers do art. All right, welcome to the artist.
All right. Can you do it?
Welcome to the, should I read it to you?
Oh, I love that. Yes, that was great. There's not that many words, right?
Yeah, there's not that much words. Welcome to artist. First off, let's try to make it simple square using turn right block and move forward block. Each side should be 100 pixels long. Okay. move forward. 100 pixels. Then turn right by 90 degrees. Then move forward. Turn right. That would be 2 sides. So yeah. 1, 2, 3, 4, 5, 6. So that's 3 sides. So yeah, I think that should be good.
Go ahead.
Yeah, I did it.
Oh, you
Awesome.
Thank you.
right. Oh no.
Draw this diamond with 120 and 60-degree angles. Move forward by 50 pixels. So goes that way. Then I think it's turn right by maybe not. Probably turn right.
Oh, so you like to try to get it right first before you even try it. That's interesting because I notice a lot of people like to just try it and see if it's right.
I'm gonna try right first.
Okay.
So I'm gonna do 120 degrees. Then move forward by 150 pixels.
So you already fixed that possible mistake right there. That you knew you had to change that number, huh?
Then we're gonna do 60 for this. And then we're gonna move forward by 150 pixels. 50. And then we're going to, that would be right here. And then turn right by 120 degrees. And then move forward by
Well, I just can't wait to see how this is all going to turn out. And my brain can't even picture it. So go for it.
oops.
Whoa, that's pretty. Look at that.
That's
Perfect.
a parallelogram.
Can't even tell you how many times I've done this puzzle, and I have no idea if it's going to be right or not. I never remember which way it goes.
All right, we're going to turn the other way. Check it out. Oh my goodness.
Awesome.
Big win. You did too well. I'm sorry. Yeah, that was like way too easy to debug. Just change your rights to left. She's got it. You have that thought.
It's
Perfect.
as if she has 2 PhDs, in computer science.
Right?
And maybe that might have something to do with it there. So it is a great opportunity to talk over like what went wrong. We didn't have to here because we had a master at the controls who was like, oh no, it's not right. It's like, okay, we're done, fixed. But there's lots of opportunities to wrestle with it inside of there. And so I think that's a great place to make people go wrestle together. And it's much more fun together too. So